This is the Amp Hour Podcast. Released September 19th, 2021. Episode 558, sponsored by Mauser Electronics. Toasted Marshmallow Connectors.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
We're actually recording this time.
We are, yeah.
I was kind of getting carried away before thinking we'd already started
the
the
audience.
show.
He's like, hey,
yeah,
folks, you may not know this one, but I'm like, Dave, there's nobody here.
I had totally forgotten that we hadn't actually started. We'd started recording, but we hadn't.
You know, Dave and I just interact like this every time we talk. So
Yeah. As soon as we log on, we start, we actually press record and then we're yapping for 5 minutes, setting things up or doing what is said in links or whatever. And so we are here. All right. Well,
maybe we'll make it a Patreon extra. You want to hear our stupid banter. You can hear it maybe on Patreon. We do release I have been releasing when we do video interviews that are like live stream. We let those go first to the Patreon. So thank you. First off, thanks to our Patrons, of course. Always. Thank you. And you get to see stuff. So if you're interested, patreon.com/theamphour. We appreciate the support.
We do. We just never plug it, do we?
Oh, yeah. Right.
We were talking about dodgy...
about plugs and hot snot around them and what else?
And dodgy reflow ovens. And which it's the T962A for those playing along at home. Yep. Is there a non-A version or has it just always been the A?
I've always seen the 962. This is kind of like, this is sold by different brands. I think they're all made in the same factory, but they rebadge them under different. I think so. Yeah. So mine is...
You buy them from 10 different sellers.
Hui. P-I-H-U-I. It was on Amazon. It doesn't really matter. Like I said, it's all in the same factory.
How much was this wonderful?
About $350. So
about $350 Yankee?
Definitely more than it would be. I mean, so we talked about the Wazoo. That's like a controller. You can get Arduino controllers. You can get, for like $100
toaster oven for your
and a toaster oven, right? Yeah.
$30. What does a toaster oven cost? $30 at your local?
$30 or so. Yeah, I'd say like $150 is pretty safe with all the shipping and other stuff you might need there, extra capped on.
So if you are on a budget, the toaster oven's the way to go. But it's not like great. I was just saying. I've got a toaster oven and an external controller, but it's just like fiddly and there's no like proper.
Yeah. I think the real thing is like, it's just so like we're going to talk about some of the downsides of this T962, but on the upsides, it is a very nice like steel powder coated case.
It's a really good form factor. It's really compact, like low profile and stuff. Yeah, it's
wide drawer. Just, it definitely has a lot of that stuff.
Yep.
But there are some downsides as well.
The first time I ever saw a photo of that, I thought, oh, it's an EEPROM eraser. Because that looked exactly like the EEPROM eraser drawers from the 1970s and 1980s.
Yep. When I first looked at it, I thought, it has like a little profile that has like the heating profile on the left side of the actual like panel. It's like on there, and I was like, well, what does it like light up? Because it's just like a drawing of this, generic profile. And I was like, how does it work? I figured there was LEDs behind it, but no, there's actually a screen to the right of it. And then it's like the logo is the profile. I was like, oh, okay. Yeah. And that makes a lot more sense. Actually
and
interactive.
Then can you change the profile? Is that a...
Yes. Yeah. So so out of the box, there's a English and a Chinese. You could switch around for the firmware. Firmware is decent-ish. And there's a couple pre-programmed profiles in there. You could also program in your own I think, by hitting buttons and, setting different points.
Yeah, right.
Not going to do that. Basically, there's there's a leaded, there's two different leaded, there's a couple unleaded, there's like a bismuth, like super low temp kind of thing. And then just like a generic drawer warmer kind of thing. I think I've seen some people use that for like, I was actually always kind of cheesed when people would use it at M-Hub, where I used to work out of. They would use it to dry out their filament for like PLA, absorbs moisture from the air. Right. And so they would put filament in there for like
really?
Like 8 hours. And it's supposed to be better for printing, fine, but like
really?
You're messing with the oven. Come on, man.
Right.
So I think that's like the easy way to, like baking out components too, right?
Oh yeah, of course, yeah. To bake out the moisture. For those who don't know, that's often when you get supplied like surface mount components,
Yeah. Yep.
a good supplier will actually send them to you in a hermetically moisture sealed package with a moisture absorber inside it.
Desiccant. Yes.
A desiccant bag. That's the word I was looking
Yeah.
for. And
Yep.
you're not supposed to open those until, the day you're going to put them into your pick and
That's
place
right.
machine and put them in.
Yep.
Because otherwise, if there's moisture inside, the moisture can seep into your plastic packaged chip. And then when that goes through the reflow oven, the moisture inside turns into steam and, well,
pop goes the weasel.
yeah, there's a lot of pressure in steam, locomotives work on steam and,
right.
it's
tiny little engines that blow up.
Hotter than the blazes of hell and damnation itself.
That's right. That's right. Oh, wow.
Back to the Future.
Back to the Future 3. Yeah.
Yes,
that's really...
3. Oh, well, hey, Chris.
That's the
marks.
deep cuts there.
Yeah. So anyway, by the way, you can get these huge industrial chip like baking ovens, like, full fridge size things. You open the gigantic door and you stick racks and racks of all your reels of components in there.
Yeah, they're more like humidors than they are anything else, like they're meant to keep it, Well, I guess there's the ones that actually bake them out, and then there's also the storage ones that are like humidors.
There's storage ones and there's baking things, and any decent pick and place, large scale pick and place house will have these and stuff like that. Yep. So, yeah.
Actually, Colin O'Flynn mentioned he actually does that as well. So he'll like throw a desiccant. So when he's storing his own parts, I think he was posted on Twitter about this, but when he stores his own parts, he'll throw a desiccant packet in there, and then he has a sealer at home, and like he'll actually vacuum out the air and then reseal it, and then
you can do it yourself. Yeah,
works well enough.
Easy.
And I never really think about that, but I have been thinking about it as I've been opening parts here because, well, I live in a much more humid climate now, and so I think it's like
right.
I actually have a someone sent me an IoT tracker, and I've been watching the humidity. Actually, I have it up here now. I could send it to you if you'd like to see it. Dave can see it. The rest of the world will not. But at night, at least outside, the humidity is 91%.
91%, and you moved to this location.
That's right. It's also nice and warm. I mean, it's great. Yeah.
Right. Okay.
So if you're, I just sent Dave a secret link, which we will not be sharing, unfortunately. But this is a little Croxel tracker.
Oh yeah.
Croxel is the company.
Yeah.
Dave, when you're looking at it, if you go in the upper right, click in the upper right, you can see.
That's where your house is.
Week.
Upper
right. Click week, and that
acceleration.
Will show you the week.
So your house isn't moving. No, your house is moved in the z-axis.
Yeah, actually, if you look at that, look at what the value is.
9.8 meters per second. 9.8 meters per second squared.
Yeah. It's Z up. Z up.
Right.
Yeah. Okay. At first, too, I was like, "Oh, wow, I haven't been moving this thing around." But yeah, that makes sense. No, that's a cool little thing. This is a friend Luis sent this to me. It's a very cool. It's a cool platform. It's all cellular and stuff. So,
yeah, it's pretty good.
Yeah.
Sound pressure level. Oh, that's not going live now.
That one is not live. That's a different firmware rev. So yeah.
Right.
Anyways, Dave and I are looking at a dashboard.
Dashboard. It's one of those Internet of Things dashboards.
Things,
which show,
things board. Yeah. But it shows the temperature. This is actually outside around here. So this is outside
it only
my
peaked
house.
at 70. What's your problem? 68.
No. You're not looking at a long enough timeline. You need to click in the upper right, and you'll be able to see a different timeline. So. Anyways, it does get much more humid here.
Last 2 hours.
Yeah. And obviously it's going to be in my house. It's climate controlled, so it's going to be
30 days.
I think I have a tracker. It's about 40% average.
Oh yeah, it cycles between 40% and 90% every day.
Yeah.
Holy crap.
Yeah.
Wow.
I mean, the temperature's dropping too, right? It's moisture.
Yeah. But it wasn't doing that back in September. Like September 1st. Why not? And all of a sudden
that's when it came online. It was offline for a long time. This has only been up for 4 to 5 days. So.
Oh, okay. Right.
Yeah.
Right. It's got some spurious data.
It is very humid here. So I have been thinking about this as I've been I was assembling a board today. I was just thinking about the LEDs and, I opened the package and usually the first thing I do is throw the desiccant out. I was like, oh.
Yeah, right.
I shouldn't do that. I still shouldn't eat it probably, but.
Right. Okay. Yes.
So, yeah.
Love it. Cool.
So back to the oven.
Back to the oven. Yes. Oh, I love how it's got 2 LEDs on the front. One's a fan to tell you the fan's on, as if you can't hear the fan, I guess.
Oh, it's real loud too. Yeah.
And I figured it would be. And the other is lamp instead of heater. It's just lamp.
Right. Yep. Lamp. Yep. I love lamp. Yeah. Yeah.
Fantastic.
So
Yep.
there are some directions. Past guest of the show, Peter Ezdentemsky, actually has some directions on his forum about modifying these things, and I've been following it because, as he writes, the masking tape that is internal to this oven will heat up and like brown up and like release a bunch of
Ugh.
like unwanted chemicals. So
Yeah.
basically, he gives directions on how to find all that masking tape and get
Masking
rid of it.
tape, just
Yeah,
unbelievable.
yeah, yeah.
Why would you not put high temperature tape inside something like this? This is
I'm not
just
sure, and there is it's like masking tape on top of like reflective metal tape, right? So it is like they are
right.
thinking about the metal stuff, but it's definitely like covering up. Like I definitely saw gaps. It was like
Yeah, but the
definitely
heat's
covering
going to
gaps.
seep out. It's not a
Yeah, yeah,
perfect insulator, for goodness sake.
yeah,
You
yeah.
know, it's like, oh, wow. That's
That's
just,
one thing. Another one is the earthing connection is not really connected.
yes,
so,
yes. For those who
so
don't know, when you screw your earth terminal to your chassis and it's powder coated,
yeah, yeah.
make sure you scrape away the powder coat
You got to
first.
get rid of that paint
Otherwise,
coating. Yeah,
yeah.
that's right. I was thinking about that. It's like, well, if the voltage gets high enough, it's going to punch through there, but you don't want it to do that.
Well, no, yeah, it's not.
You don't want to
You
make
don't
it
want to
tough.
wait
You want to
for
give
anything.
it the right incentive to just go on home.
Yeah, it's kind of important for your earth leakage because your voltage won't get there
Yeah.
to punch through. It's not like it's going to be some surge or something. It's like, yeah, you want the earth leakage to actually
Yeah.
work.
Yeah.
So yeah,
Yeah.
proper earthing. Jeez,
Mhm.
and so yeah. So he's replaced all that with Kapton tape, and yeah, I love how there's got hot snot all around the main switch in there, and the mains input is not covered either.
I don't think
So
mine had that actually. I don't think
no,
there was
no,
hot snot in
okay.
mine, so I think
You
it was
shouldn't have
just
to because that looks like one of those,
yeah, it's a screw
insert
type.
clip ones. You just, if as long as your hole's cut to the right size on your chassis, you should just be able to push in and then it clamps in place.
Oh, on the switch.
So
Sorry. Yeah.
on
Yeah.
the switch, yeah.
Yeah. Yeah.
So yeah.
Yeah.
Oh boy.
I mean,
Yep.
so I will say overall, like, generally pretty decent build quality, like not a ton going on in terms of electronics. The interface is a little bit chunky, but not terrible. But the steps I haven't taken yet, apparently the thermocouples are not, there's only 2 thermocouples. You can up it to 4. So Werner is someone who had built a board. Basically, you can go on Tindy and buy basically a interface board that'll give you 2 extra thermocouples. And then there's also a separate, basically someone rewrote the firmware, and so you can reprogram it with this firmware. And so
Right.
that's
Okay.
next steps for me. I haven't done
Right.
that yet, but that is definitely something I'd like to do.
And what does this new open source firmware give you? That
I
the
think it gives you the
stock unit
interface
doesn't?
to get the other
I was
yeah.
temperature sensors. I was going to say, how did the original unit support those 2 extra sensors? And I would have
I
found
don't
that
think so.
surprising. Yeah, you've got to.
Yeah.
I'm sure you have to reflash it.
Yeah, and so then like just looking at the the difference in the it's just like a cleaner interface. It's not a huge screen, but a cleaner interface, a
Well,
little bit.
look, after all this effort, right, of
Mhm.
physically modifying this thing and then reflashing it and installing extra temperature sensors and cleaning up, replacing all the tape and scraping off the earth connection and everything else to bring this thing up to snuff. What is the next best level out there?
Yeah, should you just buy a tool or buy a project?
Yeah,
Sort of
is
thing,
there
right?
a
Yeah.
next best level? What is? Please leave it in the comments down below if you know.
Yeah,
I
I'd
don't
like
know.
to know
What
that
is
too.
the like? I would happily pay double this if I didn't have to spend time dicking around doing any of this and it was just a quality product, right?
Yeah, I agree with that. I think there's definitely still space in the market for that sort of thing. I mean, it could just be, someone does this and just resells these. Like someone could go and buy a bunch of T962s
And do them
bulk
up.
price, do
Yeah.
them up, and then sell
Or
that.
actually, you could contract them and say, "Hey, I will pay you $100 extra fob cost if you do all these modifications for me. Sell me a better quality unit."
Yeah, right,
Right.
Well, even
Yeah.
so if you go on Wazoo, which is like the one who does the open source, I forget what it's called now. Wazoo is the company, but not the actual brand. This is the type of controller I used to have. So there was a V2 that I had, and it's now on V3, the Control Leo 3. So cool looking oven, basically generic toaster oven. He actually will do that. He'll actually sell you a completely done up oven.
Right, but it's normally a kit. I can see
it's normally a kit.
Yeah,
I think it's like $200 to $300 for the kit.
Right.
But then the fully done thing I think is like $500. So That would probably
Right.
be
And it's
okay.
just an off-the-shelf toaster oven, is it?
It is, yeah.
Right.
Yeah.
Okay.
So
Yep.
yeah, the kit is for the USA. The Control Leo itself, $139. If you want all the other stuff in with it, like all the
Yep.
extra tape and extra SSRs and things like that, solid state relays, $289. With the convection oven, that's $349, and then ready to build. Oh wow, oof, I was wrong about that. $12.95. Damn,
Whoa,
that was a lot more than I thought. Yeah.
I was just about to say there is a big market out there if you can produce. Is for all you entrepreneurs out there, all you midnight engineers out there, like a quality build, fully built reflow oven for $600-700, something like that. That's a like real quality one that's feature packed and
Yeah, right.
and it's
Open source
super accurate.
or
It's got multiple
easy
temperature
to
sensors,
modify.
Yep.
Right.
Yep.
Yeah.
Yep. I reckon there's a big market out there for that. I
I
reckon
think that's
people
right.
would happily pay double this for a better quality version.
And there was a vapor phase. There was on Kickstarter. There was a vapor phase that was affordable. I don't remember how much it was, but it was like I expected it to be like thousands and thousands of dollars, and it was more like less than $1,000.
Really, for a vapor phase one? But then you've got all the problems of sealing and the gases and whatnot. Like, don't you?
Yeah, I don't know. Vapor phase 1 was one of them, at least. I don't have a price here, but yeah, that was one of the ones. And I think there's been other. Someone else posted about this. I think we've talked about it on the show before, where they just made one. Not that I would feel confident enough to do that, because I don't even know how vapor phase works. But it, I have seen other DIY kind of ones before. So I think that would be interesting. You need to do some, at least for me, you'd need to educate me on how to safely operate it. Like, I feel relatively confident. As I showed Dave, I had this thing outside with a
outside with a fire extinguisher next to it.
Right.
we can make that
Safety
a photo
first.
for this week.
That's right. Maybe, yeah.
With a big red circle and arrow pointing to the fire extinguisher.
Yeah. And a power switch separate from it, so it wasn't like I had to get close to it to turn the power off. That was another thing. Separate power point.
Here's a UK company. The first thing that just popped up, you can buy it on Element 14/Farnells. It's 2,900 Aussie bucks.
Yeah, that's a lot.
So, that's a lot of coin, but it looks like the business. And I don't know if it's made in the UK, but it's a UK company. That's it's a little bit pricey, but something half that price, even if it was $1,000, if it was, people would.
Here's what I will say. Already today, so I had a okay experience with it today. It was a little too hot. I kind of melted some of my connectors.
Yep,
they were not probably rated for this, and it's not dialed in either, right?
Yeah,
so
some of them are not rated. Oh yeah, be careful with SMD connectors. Some of them, especially through-hole ones, they're designed through-hole connectors are often not rated to go into a reflow oven. I've done a video on this showing one that was completely and utterly melted. I've got a thumbnail of it somewhere. It's like, it's absolutely, it's just shocking the way they melt.
Yeah, and I should have just left them off, honestly. I was running up against dinner time. Yeah, so I mean, my stuff's definitely not dialed in. I know that. And it will be, but even still, it's like, okay, fine. But this was already way better than it was at MHub. Now, like, I'm not saying MHub was the problem, but I wasn't there enough to like really dial it in on those machines. So they had a Mancorp machine. I think it's like, it would look expensive, like $5,000 to $7,000. Basically the same, it's a reflow machine. The interface was terrible. It was actually a Android tablet. So the interface was not good, but the machine was like built like a champ. Very little, like vented very well. It could heat up just fine, but something about the profiles was just never quite right. And then also they had a conveyor belt style one that was from Neoden. And that's like one of the Neoden kits you can buy. So you buy the pick and place, and then it goes right into the conveyor. But that just had like PLC controllers on it, not PLCs, PID controllers on it. So that, like, it was very grunty in terms of like the actual control. It was just like you set a region. It had like a 2 bottom controllers and then 3 top controllers. You set them to different temperatures, and you kind of just crossed your fingers and you could control the speed of the conveyor as well. And I just never, even though we didn't know whether it was calibrated properly too, you dial in 280 or something like that, and it's like, is it actually 280? It's just like the PID is not necessarily calibrated right. Anyways, not a well calibrated system, and I just never had good experiences with those. So already just having like control here, I feel better about that.
Yep.
And so, yeah.
Nice.
Because when you don't have that, then you're wasting parts, you're wasting time, you're wasting a lot of stuff, right?
Yeah.
So.
And the problem is, though, is that often your profile can be different for different types of boards as well.
Totally. Yeah.
Like if you're always making little Arduino shields and stuff like that, man, you can use the same profile every time, right?
Sure.
But if you're, going from a tiny little, Internet of Things board to a giant big eight layer,
you got 2 ounce copper and you got a bunch of
then it's totally different. You have to completely experiment and recalibrate your whole thing, and you'll often have to actually destroy a few boards just calibrating your reflow oven.
Right. And that's assuming you have the control then as well, right? What if you have like differentiation between the center versus the edges? Peter's guide calls it out too. It's like
that can be a big thing.
Yeah, it's like, I used to do process control stuff, and it's like having like a flat profile across the whole thing is just you just can't really depend on that. And so then like, what if your critical component isn't properly reflowed?
Yep.
But because it happened to be on the edge of your board, it's like, oh, okay.
I know. So it's nuts. Yeah. Anyway, I sent you the link to the melted connector. So
great. Yeah.
Yeah. It's it's a bit blobby.
Yeah. Oh, wow, that one is really that looks like a toasted marshmallow.
A toasted marshmallow.
Okay, mine wasn't that bad. Mine was just more like a little bit brittle and melted.
And everything else on the board survived just perfectly fine, right? I actually
didn't put a piece of bubble gum on there that looks like bubble gum or something.
I know. This is just a classic example of that through-hole connector only being rated for hand soldering temperatures, right?
Yep.
It was not designed to go in the oven. So it doesn't matter what profile you had, that connector was going to melt. So I just, oops. Yep.
Not that, so like reading data sheets and like understanding what parts you're putting on the board and stuff like that. I had this thought today because it's not like it was actually a problem, but I soldered down 2 SOT 23-5s, right? And one of them was a single op amp, like a high precision single op amp, TLV something, whatever. And the other one was a boost converter that could do up to like 900 milliamps. And it's not like, if you swap the two, it's just not going to work, right? But like in my head, I'm like thinking just about like the difference in the circuits. And like what I was really thinking about was like someone who's coming into electronics and they look at a board and they're like, oh, like little black blob with 5 legs, little black blob with 5 legs. It must be the same thing. It's like, nope, that is not the same thing. And it's just like, we take it for granted that like these are very different functions for each of these things that are happening on board. But like for some reason today, I was just like, oh yeah, that is a stark difference between the functions of those two chips, And it's just what did I see? I saw it on Twitter the other day. Someone posted this to me. They said like silicon is just a rock we tricked into thinking.
A rock.
It was great. Yeah.
I'm sure there are geologists who will take issue with silicon being a rock or whatever.
Whatever. Yeah. Come at me, geologists.
Ask Mrs. EV blog and she'll slap us down. Right. Yep. Yeah. Not that she listens to the show ever. Does your better half listen to the show?
We were just talking about this tonight, and she said, "No, not since we started dating."
Right. So she has no idea what we do on here.
No. Right. No. I mean, come on, she would not care. Yeah.
And not care, right? Because she's not in the industry at all.
No,
she's not. No, yeah.
No.
Yeah, we won't say which industry she's in, but
Yep.
It's certainly not. What can we say? It's one of our arch enemies, almost.
Sure. It's fine.
Kinda, sorta.
Yeah.
Anyway.
Yeah.
No, everyone's thinking marketing. Everyone's thinking marketing.
She's not interested. No, I could say that. Yeah.
Yep. Oh boy.
But yeah, it was just, it was okay. Like I said, it went okay today. Melted some connectors a little bit. I'll be able to replace them.
Yep.
The bigger mistake that I made on this board is actually, SMT. I love SMT female headers. I think those are like great. They're really expensive, but I always get it wrong in terms of which pin starts on the right or left. They're like every other side. And I got that wrong. And so I spent like probably a half hour today of just like pulling these pins out and flipping them around.
Right.
Because you can actually, so like these are like, it's basically just like a 16 pin receptacle. and it's just a little piece of formed metal that's in there, and the pin's sticking out one side or the other, and so you can just pull it out and flip it around. So I spent a half an hour doing this, and then I went and melted all the connectors. So
yeah, well done.
yeah, we'll do that again tomorrow.
Classic. Oh boy.
Yeah. Here on the Amp Hour, we look for sponsors who help our audience learn. Today we're talking again with Paul Galata, who is a senior technology specialist with Mauser Electronics. We'll be talking about industrial automation. And I asked Paul some of the applications he considers to be, quote, industrial.
Ag tech is one, even though that's probably not something that we think when we think industrial. Automotive is heavily industrial. That's really in several continents where I would say that that's a lot of heavy industry going on with machines and robotics. And then I think there's a lot of things when I take something like Mauser, what I'll call another big area that, again, people wouldn't think is industrial, would be like warehousing. I'll call it logistical control. But imagine what's going on in a world of Amazon and what they're doing. They're incorporating robotics and vision systems and automation and processes, all these things we're talking about to get things from A to B.
It's interesting to consider logistics as an industrial control system, but anyone who's seen inside a logistics facility will agree with that given all the moving parts. What are some of the industrial automation elements that allow operations to operate without a human in the loop?
There's a variety of things that have been tuned and automated such that the process through the system has a lot less people than you might imagine touching anything per se, and a lot of automated decision-making thing by machines in computers so that hundreds of millions of shipments can happen with very little error, with very high precision, reliability, control. We think of industry as probably a lot more of nuts and bolts and clamping televisions together and those type of things. And that's certainly there, but it's a different type of economy now, right? The digital economy that's demanding this type of agility and ability to go, I don't know what people are going to order, but what am I going to do once they do, and be able to pull it in an automatic way and do that well.
I asked Paul about how IoT plays into the industrial space.
As we've increased with things like artificial intelligence, as we've increased with the ability to have wireless within the industrial space, now we can connect so that the machines, the processes itself have a little bit more human type of characteristics. The wireless connectivity, for example, gives us the ability for those machines to communicate both amongst themselves and off to different control centers. AI and machine learning give the ability for it to have more decision making that looks to be coming from itself. We know it's programmed by humans and set up accordingly, but we can put that into place so that the machine can just do that repeatedly and reliably within those parameters. And then things are becoming, just cheap and ubiquitous, so people can see that, hey, we can take these mechanized ways that we're doing it and augment and make things better. And I think some of the advantages behind that is, one, there's always kind of a labor savings and thus maybe a cost savings behind doing that, right? If we can make the machines do things on their own and control themselves, we can eliminate some of the labor component. And so there's always a drive to be more efficient and more productive in industrial settings. And the more we take out the human element, the more we can squeeze a labor cost. And then there's a repeatability factor. If you automate things, generally what that does is the process becomes very, very controlled. There's much less aptitude to go outside the boundaries, or if you do go outside the boundaries, to immediately correct or adjust or shut off or whatever is the appropriate action. So this idea of consistency and reliability in a world where you want to go, yes, I'm guaranteed that this product or this end result will always be the same. That's what people care about. They want to know that the quality is embedded into the process. And I think that's one of the reasons, motivating factors why industrial automation is so important, because it gives some of those benefits.
To learn more about how Mauser is enabling industrial IoT, industrial automation, and generally connecting more machines together, check out theamphour.com/industrial. And now we're back to the show.
All right, news that just broke.
Sad
Well,
news.
I just heard this just minutes before the show. Sir Clive Sinclair, someone I've always wanted to have on the show, but he was apparently but he was not a technology guy. He didn't own a computer, apparently. He didn't own a smartphone. He didn't, partake in modern society.
Yep.
Yeah.
Did his own thing. Made his own
Yep.
Ugly ass vehicles.
Sadly, he passed away at 81 or 82, depending on who you read. But he, like Sir Clive Sinclair, the British inventor, I guess, for want of a better.
So what were the run down the things that he did again?
Oh, come on. What didn't he do? He basically invented low-cost electronics consumer products. He started out, I don't know if he started out, but it was one of his early ones was the Sinclair Scientific Calculator. This is just after, this is in 1980, 80, God, no, the early 1970s, 1974, where the HP 35 was, of course, the first pocket scientific calculator, right? Famously.
Really expensive, though, right? That was like, wasn't that really pricey?
It was $300 at the time, which was a lot. Oh, yeah.
Yeah, that's like buying a computer now, right? It's like buying a MacBook, you know?
Steve Wozniak, who worked at HP in the calculator division, he famously sold his HP 35 to start up Apple. You know, he famously, like Steve Jobs sold his van or whatever, and the Woz sold his calculator, and so they were quite pricey at the time, but it was it was revolutionary, right? Yeah. So anyway, that had been out for a couple of years. That was 72, I think. And that famously used it used 5 different chips in it, and then Sir Clive Sinclair came along and he said, well, I really want to make like a low. Can I sell this for like 1/3 the price? Can I sell it for $100? And it's like, sorry, it was $400, I think. $400 for the HP. And he said, can I quarter that? Sell it for $100, a scientific calculator. And that was like, no, you can't do it. Texas Instruments.
Just because I looked it up, $400 in 1972 is the equivalent of $2,600 US dollars today. So that is a MacBook.
For a pocket calculator.
Yeah, so that's a MacBook, right?
That's a MacBook for an
expensive high-end computer.
Scientific pocket calculator. This is why they had them in their pouch. You had a belt clip for it, and you had, baby.
I mean, it's also so you can show it off as you're, strutting down the street.
Exactly. Yeah. Just like you walk around with your Apple these days, flashing it around. You flashed around your HP 35.
Right.
With your, even though it did fit in a pocket. No, you wanted to put it on your belt, so that people can, see it. And anyway, so he said, why can't we sell this cheaper? And TI at the time, they had just released a calculator chip, but it was like a 4-banger calculator. Like it didn't do any, so it couldn't do any scientific functions. It had NAFL memory in it, and it just couldn't do it. And TI said, no, you cannot turn this into a scientific calculator. It just doesn't have the resources. And Sir Clive Sinclair said, hey, you want to bet? Yeah, they famously did it. They used this cheap ass 4-banger TI calculator chip and turned it into a scientific calculator, and they sold it for $100, and it was a huge success.
It's awesome.
I don't think it sold as many as the HP, because HP
sure.
Like, this was built much cheaper, and, but still, that was like groundbreaking.
Yeah. It's whenever people think of like innovation, they always talk about like, oh, it's always like the next hottest thing. It's like the next breakthrough, but like this kind of like cost down type innovation,
optimization, yes, making cheap products with what you've got available.
It makes it more broadly available. It makes people more interested in it. It brings in more like total dollars, so more people enter the fray from like the combination of economics and technology, and like looking at the actual process optimization that happens in there. Like, man, there's just like, this is a super important piece of moving technology forward, because then it also frees people up to do that next thing, to do, then the bleeding edge innovators are working to race ahead and to make the next dollar on the high margin thing. And so like, this sort of stuff is really important.
It pushes everything forward, and it didn't even work properly. Like there were you had to read the manual. It was like a spec sheet for chips. It was well, you can't use it under, like, you can't do logs under 1 or whatever. You can't do logs under a certain value because it doesn't, the algorithm doesn't work. Sorry, it's that's out of spec, right? It'd give you a result, but it'd be wrong, right? So this calculator did not give you a correct result if you used it outside the boundaries.
I've never been in that. I've heard you talk about it. I've heard other people talk about it before, where they say like, oh yeah, you have to know that sometimes this calculator's wrong. In my life, calculator's always been right or right
It's always
enough,
been right.
right?
Yeah, exactly.
Yeah.
And
that's
well, and
interesting.
the HP 35 was right because it was designed by a proper engineering company, spared no expense. Well, not I wouldn't say they spared no expense, but they did it properly, right? The HP would not release a calculator that gave you a wrong result, right?
I thought there were still like limits though of like like 5-6 digit kind of stuff.
Oh yeah, yeah. No. There were limits to the precision, but it would never. There was nothing you could do on it that gave you an incorrect result, whereas the Sinclair could. But because you only paid $100 for it, like you were willing to live with that, right?
Yeah.
And it was like, no problems. But yeah, and then of course the famous ZX80, of course, and ZX81 computer. When did they come out? Was it 1980? Hence the. Well, no, it was ZX80 was because it used the Z80 processor in it, but ZX80 wiki. Sorry, I'm going to go to wiki. I should know this, being the computer. 1981, no, discontinued 1981, released January 1980. Yes, I was correct. And this was unheard of. A home computer for £99. I'm going to say it was £99.
It says. This article says 80 pound in kit form, 99.
Yes, you could get it in kit form, or if you wanted it built up.
Yeah,
this was unheard of. Like at the time, the other competing
Plus the design
computers
on this thing. It is just It's
and
very
he used a was it a Ferranti programmable logic device in it to reduce the number of chips, or was that in the ZX81? Because the ZX81 only had like 4 chips in it or something. It was just insane. He just he knew that cost was everything, right? Sir Clive Sinclair was the master of cost, and everything he produced was produced down to a cost price point. Actually, and this is not due to labor. Right, this is not. We're going to make it in China, and that's how we're going to get our costs down. This was using engineering nous to produce a product optimization, to produce a product that's just good enough.
Yeah.
And meets a price point, So he would go in and say,
Munsing take to another level,
months into another level. It's Sir Clive Sinclair, and it worked because he would start with, I want a £99 computer. That's it.
That's the crazy piece. Can you imagine just pulling a number out of your ass,
and just being out of your ass and trying to make it happen? And that's exactly what he did. And he was famous for it. And then he got into portable televisions, and which I've done a teardown of, a Sinclair portable TV and little,
that
CRT.
little CRT on that.
They're amazing.
And then of course that ridiculous vehicle that you've been. Well, obviously we've talked about on the show many times.
The Sinclair C5. Yep.
Yeah, that's a. It's very, very stupid. It's just but for the time, it's fine. It's fine, Dave. I'm just saying,
it's fine. I know
these other things kind of feel like kind of in their time, and it feels
once
like the
again,
C5
it was so cheap, right?
Someone that's coming around Epcot, someone was
right,
at Epcot, and it's this thing that was like a exposition.
Yeah. Please explain Epcot for those who don't.
Oh, sorry. That is a part of Disney World. It is where there's many different. That's where many Americans first experience overseas cultures. Is at Epcot.
It was the land of the future. It was,
That's right.
It was like, you could go to see futuristic things, and
that's right.
Yeah.
Actually, in Buckminster Fuller, the geodesic dome. That's the Epcot Center symbol is a geodesic dome as well.
Right.
So. Pretty famous from that perspective. Yep.
But I don't know. It still happens these days. People go, right, I'm going to sell a $9 computer, and out pops a $9 Raspberry Pi thingo, cheapo thing or something.
Yeah, it is interesting when it starts from the price. One thing that I've noticed is actually on the Kickstarter and crowdfunding type sites is that those are often the most popular ones because you grab attention with oh my gosh, they couldn't possibly make it that cheap, right?
Cheap,
Raspberry Pi as well, right? That was Evan and his team saying $35 computer. People are like, well, people like Dave and I, right, right. And so and obviously they've delivered and they've had crazy. The Raspberry Pi team who came on the show, they talked about their cost optimization and how that was always the first thing that they look at. That's the first thing because they want to get wide adoption. It's that's another. think that they maybe are the bearers of this torch. I think, like they are cut from the same cloth, I think. So yeah.
We did that at Altium, actually. That was, I've talked about this in.
No, you did not. Dave, 3 weeks ago on the show, you talked about a $4,000 dev board.
Yeah.
Mic drop.
But you didn't let me do the follow-up. Okay. It was the $300 one. That was set.
Come on.
It was the price. No, that
I will
came
give you
down.
an equivalent. I will give you an equivalent. What? The ST Micro's discovery boards at $9 are the dev boards.
Yes, I know, but I'm trying to explain that was the thing, right? That came down. We want a $300 board, right? So that's what we designed around.
Right,
okay.
Right. But whoever was pulling that price out of their ass was not pulling hard enough.
well, you could argue that it's better than $4,000, right?
Sure,
but
sure,
it's I'm saying that is the process, right? That's when we had to try and meet that cost target, right? Yeah, so that came down.
No doubt,
$300 board.
I have a similar anchoring problem. When I was at Keithley Instruments, they start from a $6,000 source measure unit or a $6,000 DMM, and they say, we're going to make a low cost DMM. And they say, okay, what can we get off? What can we get rid of this thing? Well, how about this $35 GPIB chip that we pay for? Oh, no. Customers definitely need GPIB. Seriously? That's what you're going to say there? Well, what about these really expensive op amps? And well, we have to have the specs. And then you go through this entire list and you're like, I guess we have to make, the low cost DMM is now not $6,000. It's $580. $5,850. It's like, yes, we've done it. But low cost DMM.
Everyone gets a pat on the back, and
that's right. Yeah. Bonuses all around. The price went back up. Don't get me wrong. If any of my Keithley coworkers, former coworkers, are listening, I love your products. Don't get me wrong.
I'd argue for that in like the $300 Altium dev board. It's go, no, we need a better spec on this ADC, and they go, we can't do it for the price. And I went, bullshit. Right. And a day later, I came back with a part that I found we could, a way we could do it.
I feel like these kind of things. So like, this is all like innovator's dilemma type of stuff too, where it's like, you basically, so again, to remind people of the innovator's dilemma, the book and similar things, case studies that Clayton Christensen always talks about, is basically, if you're coming from the top down, it's always tough because you always have these kind of like anchored positions. You have people saying, no, we need this thing. And the idea is that the people coming from the bottom up are starting from a good place, right? So like you have a Honda building super cheap cars with like no frills at all. And then they move up into a more complicated market later, but they get a lot of market share before then. And it's just like, so just ripping everything off of there. If you're starting with a computer and you're saying, it has to have a screen, it has to have a keyboard, it has to have all these other things. And then Raspberry Pi comes along, it's like, well, it's a circuit board. Using a media processing chip that we get for really cheap. It's like, that's a totally different context then. It's just, it's just, you have to completely change the game in order to do that sort of thing. I think one thing that was impressive about Sir Clive is that he still maintained a lot of the form factor and a lot of the things that were really tough.
He tried to, but he managed to do it. Like he figured out, engineering ways to do it. It's like, like he knows that the per chip cost. So, let's design a 4-chip computer, totally. Can we do this in 4 chips or whatever, And it's like, And it's like, yes, you can. It's the answer. Yeah, it's amazing. So,
well, rest in peace, Sir Clive. Sorry we couldn't have him on the show, but,
that would have been great. But
would have been great.
Classic character. Anyway.
Yeah, definitely.
Yes. Rip Sir Clive.
Yeah. What else is on our list? I guess not much. I haven't really been adding much.
Maximo. Yeah, goodbye, Maxim.
Yeah.
Grown.
Yeah. I did have a point today where I could not get a TI chip, but I could get a Maxim chip, and it was just like, just
really?
random.
That's
I was like,
that's
this is
funny.
This is a different thing. Yeah,
for those who don't know and haven't heard us say before, Maxim used to be the masters of unobtainium.
That's right. Yeah.
Sorry, you could obtain samples, but you want 100 of those? 40 weeks, sir. Thank you very much. It was like, but they had everything. And to actually carrying on from our specifications, talk we were just on about.
Sure.
The Hanovolt Design Challenge Nanovolt Design Challenge
this.
on the
So
EV
what is
blog
this?
forum. Yes, this is user Tin on the EV blog forum, who's a Volt nut, and the EV blog forum is there's a Volt nut section on the EV blog forum. Right, yeah, there's some hardcore Volt nutters on there, right? And they're their own little community.
Sorry, we've defined this on the show before, but could you please define it one more time? Volt nuts.
A Volt nut is somebody who's obsessed with having the utmost precision, the utmost resolution in their measurement equipment. So
they basically go to sleep dreaming of LTZ 1000s every night.
You've got to at least have an 8.5 digit meter to be in the Volt nut club. 7.5 digit, no, that's for hobbyists.
Oh, come on, how dare you?
And it's like, exactly.
Get that weak sauce out of here.
and these guys count ppms, right? They dream and think in everything's ppm, right? Everything's parts per million. And it's like, and they will develop, and they'll design their own custom, jigs and things to, age in their temperature references for 6 months. And, it's like, I don't want to compare them to audio fools because it's not, right? But it's like, oh yeah, like I need to burn this thing in and then it will perform better. But they, as opposed to audio fools, they will actually back it up.
Well, I mean, there are people. There are some people that are legitimate, like about noise figures on.
Oh yeah, no,
it's
getting
right?
the
There
utmost
are people.
lowest.
They might not be able to hear it, but some people in the audio field actually can measure that stuff. And anyways, I feel like there are two groups in there.
No, but the Volt nut crowd is all about reels versus reels and certainly not feels, right? It's this one. I think I believe this one measures better. No, you prove it. Like
I'm just saying in the audio, there is like THD.
Yes,
people
I
that are crazy
know,
in the audio field. But that is not the ones that we usually talk about. So,
no,
they're not as fun to laugh about because they actually measure things.
Yeah, that's right. Yeah. So anyway, he's laid down this contest. It's on xdevs.com at Nanovolt Challenge, and there's like the rules and acceptance for this sort of stuff is like and what's suitable and what's not. And I haven't read every post, but like there's argument. I can see arguments in there about why does it have to have this interface, and why can't it have this interface, and et cetera, et cetera. And they're all arguing over exactly the terms and conditions of the challenge. It's like what rule, why can't I have a Ethernet interface version, and it's got to be RS-232. It's like it's great stuff. Great stuff. Anyway, this is like it's a 1 year long challenge. Who can produce the best nanovolt meter in the next 12 months? And it's like
it's gonna be the one guy who could source parts because he had it in his lab. Yeah.
But the thing with all this stuff, the Volt nut crowd, is it's not just about like you just don't buy an LTZ 1000 reference and that's it. I'm a Volt nut. Right? It's all about how it's temperature compensated, how it's mounted, and how it's, like all sorts of things. Just the design of the PCBs in the Volt nut world is an art form, right? Like they have special cutouts because if your board thermally expands a little bit, then that could put uneven tension on the legs of the IC, which then subtly puts pressure inside, and then that can change it by 0.1 parts per million. Right, that can change your drift if your PCB expands. So they'll put all these exotic cutouts in their PCB and stuff, it's just it's
so what is
it really is very
submissions
cool.
Must be completed by September between September 2nd and 2021 and May 16th 2022. So you need to write about it. There's no budget limit. Designs must be verified. You must have noise figure results.
Must have 10 nanovolt resolution, noise better than 30 nanovolts peak to peak, over 0.1 to 10 hertz, auto zero capability. Okay. It's got to, it's got to be galvanically
but the answer is
isolated.
It's just a measurement device. So you're just measuring.
It's just a measurement device. You're measuring nanovolts, right? So
it's not doing some like crazy. There's no like spec you have to meet. You have to just do the best you can, basically.
Oh, right. No, there's a spec. You've got to have a range plus minus 100 microvolts up to plus minus 10 volts. It's got to have multiple ranges. So
interesting.
Yep.
Huh.
So it's got to have certain ranges, and it's got to 40 watts total input power budget,
Okay.
because like you do need a power budget for this,
Yeah.
because like you can't just throw 1,000 watts at the heater, and it's like, look at the thermal mass in this baby. I've got a 1 foot cube of ceramic, and that's being kept at a certain temperature by 1,000 watts.
If there's ranges, you have to have 100 microvolts. And also have a 1 and a 10 volt, which means you also need to have switching in there.
You've got to have
that.
attenuation. Yes.
Yeah.
Attenuators at this sort of noise level is incredible, because those who don't know,
right, putting resistors in line with
Johnson
1 over F
noise.
noise.
Hello, Johnson noise. Which is based on the larger your resistance value, the higher your intrinsic noise.
Yeah.
Of your resistor, and that's going to ruin your day.
I used to support the 2182, which is like Keithley one, but like. That was a nanovolt meter, but it was just like, I didn't know what the hell was going on in there.
I have torn down. I tore down a picoamp meter. No, I tore down a nanovolt model, didn't I? As well.
I don't know.
I've got a Keithley here.
They haven't updated that one in a long time. It's interesting because there's that, and then there's also but what most people are usually looking at with these things is actually another link that we have on or maybe this is what Marco was talking about. Marco Reps made a video about the HP 3458A. Why is the 31-year-old multimeter unrivaled? And so basically, I think that's really what people are going for. Is not necessarily the nanovolt meter, which didn't have that many ranges, but the 3458 is like an 8.5 digit. Like it's just it's the one, right? I mean, like that's the. Do you have one of those or no?
Sorry, no, I haven't got one. They're like $5,000. Yeah.
I think
Martin
Lorton has one. I think.
Yes, he bought one, and everyone's going, "Why did you?" But he got sucked into the volt nut vortex. Yep.
And I think Shariar has one. I think I see one on his bench.
Yes, he got one, and there's a couple of others that have.
I've been around them.
3458As, and it's like it just uses an LTZ 1000, right? So why can't you just buy an LTZ 1000 for $30 or whatever, whack it in there, and you've got it's like
everything in front of it,
it's like go and look at the sampling capacitor inside a 3458A. What is the sampling capacitor in there? It's Teflon coax. It's Teflon coax, because that's the only way that they could get the stability in that higher a capacitance value, was to use like 5 foot of rolled up coax, Teflon based coax, right? For the sampling capacitor, for goodness sake.
It's bonkers.
It's it's nuts, right? It's just it's crazy. And there's countless other things in there as well.
I won't be entering this contest. I don't know about you, Dave.
No. You have to devote your life to stuff like this. It's not something you can just go out and do. Like, it's not something. I'm into microvolts and nanovolts and everything else. But it'd take me the rest of this year working on this damn thing every day to.
You're such a troll. I just saw your comment on Marco's video. No wonder it failed at the 21-minute mark. You mounted the DMM on its side. This causes all the electrons to fall out the bottom of the hybrid chip and floods the ADC. You troll.
Did that get a thumbs? Did that get any thumbs up?
Oh yeah.
Did it? Yeah. Is that how you saw it?
Yeah, that's right. Yeah.
Is it right? Let me I'm going to have a look. Yeah, I couldn't help. 190 thumbs up. Yeah, that's why funny. It appears at the top.
Boy. This
what?
guy.
What? Come on.
It's
you
funny.
Don't think that's real? You don't think that's a real phenomenon?
Yeah. Actually, I do think that there are problems with mounting it on the side, but it's actually not tied to electrons falling at the bottom. It's more about airflow.
No. Well, don't turn your frequency counter on its side.
What's that?
You don't know. You need to watch my video.
I'm not going to. So if you could just tell me, that'd be really great.
It's called 3G tip over. And it's an
you could just be totally blowing smoke right now. I wouldn't know the difference.
So, right. Okay. Hang on. I'll send you the video.
Yeah.
It's how you can use your frequency counter to detect gravity.
Right? Interesting. Okay.
Yep. Here it comes. Incoming. Okay. And what it is, it's a phenomenon inside crystals that, 2G tip over. What did I say? 3G tip over. 2G tip over. It's
3G shut down now, so that's 2G is still active some places.
2G tip over. Crystal oscillators will change frequency depending on their physical orientation.
Huh. Because of how they resonate, like
It's how they resonate.
fork?
Gravity actually,
How the
yes,
fork
the
happens?
acceleration due to gravity
Yeah.
actually affects how a quartz crystal oscillates. And if you've got a high enough precision frequency counter, you can see it. I'm talking like you need 12, 13 digits before you start to see it, but you can see
wow.
it. And I demonstrate in my video. I've got my Agilent frequency counter with my ovenized oscillator, and I turn it on its side, and it changes frequency. The internal reference oscillator.
You know what, Dave? You sold me. I'm gonna watch it. I'm gonna
Yep.
watch it. Yeah,
Yep.
that's pretty good.
Yep, a lot of people don't know this, and I actually released this on April 1st as well, thinking along with
No,
another
this is
video
July
on
30th.
April 1st. Yeah,
This is
it
July
is,
30th.
but it was actually released midnight, July 30th. Yeah, a lot of people thought I was joking. A lot of people thought this was an April Fool's joke. It's not. This is a real phenomenon, and it's you can detect orientation and gravity of your crystal based on its orientation.
Cool. Yeah,
Yeah.
that's great.
Yeah, 2G
It's
tip
just kind
over.
of crazy that like sometimes when you think about the fact like how many things are controlled by crystal oscillators, and it's just like, oh, it's just like
yeah.
a little vibrating rock. No big deal.
Yep. No big deal. And yeah, a little vibrating bit of quartz. It's absolutely amazing. And you know, I found this. I didn't discover it, but at the time I didn't know this was a thing, right?
Yeah.
As almost nobody knows this is a thing unless you're working on the extreme precision end of frequency measurement, which I was with my underwater sonar stuff, right? So we're using rubidium oscillators, and we're tracking long-term tracking and stuff like that. And I discovered that if I mounted it in a different orientation, that would change the frequency, and that would ruin my day. And and sure enough, I researched it, and it's a thing, and it had a name, 2G tip over. It's like, I can. And there's papers on it and stuff like that. But yeah, you can measure it in your own lab if you've got a high resolution frequency counter and a rubidium and an external reference. So the way you do it is, of course, the frequency count. Well, no, you could do it with just the frequency counter as the reference. As long as you've got a stable enough frequency going in, you can tip your frequency counter and you can see the difference. Very cool. Very cool.
Yeah, that is very cool.
There you go. You learn something new every day on the Amp Hour.
Mm-hmm.
Yep.
Unless you watch the EV blog, then you're probably
Unless you watch
already
the EV blog and then covered back in 2014.
Unless you watch every video. I watch a lot of
every
it.
single video.
Don't get me wrong. Come on.
Yep. But no, that was yep. There you go. All right. What else we got?
I think we got to talk about this one is just bananas. Like the semiconductor heist of the century. This is basically ARM China.
Oh,
this is
China.
ARM China.
Yeah, right.
You know, so ARM. So people don't. I don't know all the details here, but I know anytime I've heard about companies wanting to go do business in China, basically they have to be a wholly owned foreign entity, or WOFE. I just remember companies talking about WOFE.
WOFE? What?
WOFE. WOFE. Wholly owned foreign entity.
Oh, okay.
WOFE.
Right.
Which means that basically you can't be a majority shareholder of a Chinese company operating in China. That's how I understand it. I'm not saying that's how it is. That's just what I know. I think ARM was also in the same place. They wanted to go operate in China. There's a ton of chips made in China. They want to work there. Yep. And there is basically they form a new company that is effectively ARM China, but it's called something else. And in this article, they keep referring to it in the simplified Chinese that I do not know how to say it. So I'm not going to. So I'm just going to say ARM China here. But basically, it's a different company.
Yes,
and then,
it is not part of ARM. It's not part of the ARM company. They basically had to split it off, and they thought that they were doing good business in China. It's like,
Well, so then you do tech transfer, right? You basically say, okay, we're going to move some IP over there. We're going to go and make stuff with this, and then they just stop talking to them. I think
exactly.
It's just like, oh no, we're our own company now. We're gonna thanks for the IP. We're gonna go. It's just like, holy crap.
What are you going to do? We have nuclear weapons.
I mean,
it's like, come on.
I mean, like that's It's just crazy. This the whole thing just reads like a I don't know, like a Grisham novel or something like like some kind of like high stakes novel because it is right. I mean, like it is.
But like, welcome to China. That's how it works. It's an authoritarian state. They do whatever they damn well they like, and it's
Huh. Interesting. So there is an update at the bottom that I had not seen when I first posted this article, and you also posted at the same time. Update 8/31/21, emphasizing that the IP has not been stolen or stopped, according to ARM. Semi-Analysis, which is the publisher of this blog, maintains that the heist occurred regarding control of the ARM China entity. Because there is also the talking about Alan Wu about like basically they just kind of lost control of the whole company. So ARM says the IP has not been stolen, but they don't have any control over it.
They have no control. No, because
yes.
No, in China, ultimately, when it comes down to it, the Chinese government
Government's in
own
charge.
your company, right? They own your company, they own your land, they own, it's like
crazy.
it's like technically here in Australia, like the Queen owns my gold or something, like it's like it's if you take it to its further enough extreme, it's like
So here's an interesting point for this article too. ARM has been shaken to its core with the second largest market snatched from underneath it. According to ARM, no IP has been stolen. However, ARM cannot license directly to any firm in China. They must go through the name for ARM China, which is in Chinese. I don't know how to say it. Sorry.
Yeah.
Wow, that is just bonkers. It's basically like getting locked out of just everything
of
else.
Course. Yeah. No, that's what happens if you do business in China. Yeah.
Well, I keep seeing all these news articles. So obviously we are in the midst of the worst semiconductor crisis that I've ever heard of. I don't know about you, but I'm having a hell of a time, and I'm not even touching.
Dude, I can't get new
beans.
multimeters until first or second quarter next year.
Oh, totally. Yeah, I mean like that, and that's nothing. I saw someone posted a picture of an STM32 lead time, and it said available 1/1/2027.
That's great.
Why don't you just put
great.
like either one of two things, either never or screw you, stop looking at this page.
Dreaming. Tell him he's dreaming.
Yeah, just tell him he's dreaming. Right?
Australia.
Yeah.
That's just.
But I just saw an article that was like, well, one of the things that was happening is that UMC, which was a China fab, that was offloading a lot of stuff, and it's just like. But now they were saying, "Oh, we're moving stuff out of UMC." That I don't know if it's a trade war thing. I don't know. Like there's so many like big moving parts here that I don't have any idea about. Yeah, but all I know is I can't buy a goddamn part that I want to get, and it doesn't seem like this is getting better anytime soon. Nor am I hearing that from anyone. Nobody is saying like, "Oh yeah, it's about any better in 6 months." Nope. It's hold on to your butts for the next 2 years. It's like, oh my god.
There's quite a few companies, especially the automotive ones, that are publicly coming out with things saying that we have a roadmap for getting back into production in the next 6 months and stuff like that too.
Yeah, but how do they know?
Prices. They don't.
You got to have every single. This is the downside to hardware: is every single part has to be right on the board. It's like, man, one part and you are lying down.
Yep.
It's just it sucks.
Yeah.
I mean, in terms of like redesign skills, it's never been a better time to be a engineer who can learn a lot about designing in similar parts. Whatever's available, you got to go and evaluate quickly. There is a lot of design to be done. It's not a slow time for electrical engineers. However, it is not a pleasant time for electrical engineers. It is a bad time.
Oh boy. Yep. Yeah. No, not good. Yep. Anyway, heist of the century. Yeah, it's great.
Yeah, it's really interesting. I one thing I'm really curious is, we talk about RISC-V a lot on the show, and I'm just very curious, one, generally about uptake in China. I think that's going to be very interesting because I think that will leak back out as like other IP type stuff. And then also just moving outside of like licensing models entirely. That it's not actually it won't be outside of licensing models.
I'm surprised at how quickly the RISC-V thing has taken off. I think there's a lot of people. There's something here. Like people are realizing that this whole ARM thing. It's
people
like
were
we're
telling
going to
us
come
a couple years before that,
right? So. It's like Yep.
I do think market forces are accelerating things in that space 100%.
Right.
I mean, like it's without this kind of stuff, without trade war, without the shortages, all this other stuff. Like I think it probably would be coming up in a similar amount of time, or sorry, not in a similar amount of time. It would be coming up, but I don't think it would be accelerated like it has been, like in terms of the announcements and whatever else.
Yeah, no, it just seems too quick. There's,
I think the downside
driving
is that
force behind it.
There is still a lot of lack of capacity, right? I mean, so
Oh,
like
yeah.
even if you wanted to go and build a fully custom RISC-V compatible design using licensing from an individual or based on your own design, whatever, it's like you still got to build the chips, and that is one of the hardest things right now. So it's like,
And I just saw, I think it was news today. Did I see it on Twitter that TSMC have just raised all their prices 20 or 25%?
That's also on our subreddit, but yes, it is.
Okay.
Yeah,
Right.
Yeah,
It is.
yeah.
Okay. Yeah, they just raised prices across the board. Like,
Yeah.
Yeah. There we go. And
what are
chip
you gonna
prices.
do? Like
You can't. Yeah, I
they
know.
are the juggernaut, right? I mean, like, yeah, okay,
You can't
Intel
do
is
anything.
got a foundry business now. So what? Intel.
Oh, I guarantee.
is expensive, high end.
Just like assembly, right? You can pay to have other companies bumped from the production line, and your boards, either bare boards or assembly boards, you can pay more to have them bumped up the production line. And that's what I guarantee you. There's companies out there that are going, we don't care if we make a loss on these cars, right? We need to start shipping, right? And they will pay to pump themselves to the top of the queue. Yeah. So if you're waiting for your
it's not real until it's in your
chip,
hands.
you're not going to get. That's why the lead time just goes out to basically, they cannot give you a lead time. They just don't know. So they just whack on, 2027 or something, insane. It's just, wow.
One thing that I was discussing with people on the consulting forum was like, kind of suggestion by me. I'm not sure if it's actually a good idea, but one thing that happens on a lot of my designs is like they're very integrated chips, right? I mean, like even to the point where like I'm doing SOMs and just, whatever I can get at this point. Like on this board I just assembled today, it's like, it's a buck converter module, but it's basically the size of like a SOIC 14, but it's got everything. It's got the inductor in there. It's got the whole thing. It's
nuts.
A cool little module, but like that's got everything in there.
Yeah.
Right. Yeah. It's way too much, but it's, it's available and
it's very convenient. Yeah.
Totally. Very convenient. Yeah. But do you go in the other direction, right? So now if you can't source parts that are like super specialized, so just use a buck converter again, right? Like TI parts are very hard for me to find right now. Anything automotive obviously is out the window. But just even general TI switchers or some of the linear regulators, hard to get. So now do you go in the other direction? Say you're so like I'm making boards that are very lusciously large, I'm not space constrained at all.
Right.
Do I go in the other direction and say, okay, well, actually I can build a switching circuit using a 555. Not that I would do that actually, but say I could go and grab a small micro that's available.
You use an op amp, you use a transistor, you use a pass transistor, and you whack in a little.
Right. Do you do that? Is that more or less responsible? I think from a personal enrichment perspective, it's actually very one thing. It's something to do while waiting for your other parts to show up. But I think that it's probably not that responsible in terms of like long-term development. But as like a workaround hack, I don't know. Like it's like you can probably get 2 N7002s, or you can probably get 1 N914. Like you can probably get some of the jelly beans and build stuff, and you might give up some percentages, but I don't know.
Who cares? It allows you to make it.
But you can also build it. So like, what is the true what is the lever you have to push at this point in order to just get stuff out the door? Maybe that. Right. But I think that that might be going in the other direction, less integrated than it has been, and like less feature rich. And then like what comes of that? I don't know. Like it feels like there's not many options if you really need to get something out the door. And so like it'll be interesting to see if if you start doing teardowns 6 months, a year from now, like do you start seeing that more in commercial products? Do you start seeing that more in prototypes? Right. Are people listening doing that right now? I'd love to hear. Like just what are people doing to get around this sort of thing? Because oftentimes
do we
sitting
see
on your
more bodge boards in there?
Sure, exactly, yeah.
Because you don't want to respin your board, but
you don't want to respin your board, but like you also can't just tell your boss
that little power module.
Yeah, you can't tell your boss, oh well, we got to wait 6 months. It's like go do something. I'm paying you.
Exactly.
The other option is I stop paying you. It's like, oh, okay. So it'll just be interesting to see how people do this in a broad basis. So would love to hear if people have thoughts on that. It's very interesting. A lot of videos to be made here, Dave.
We're way over time, dude.
Oh yeah. I figured that was my wrap up. That was my wrap it up.
Okay.
Leave a comment down below, like, subscribe, and hit that bell.
No, you can't like us, really. You
People
can't.
can like us, Dave.
We don't have a thumbs up thing unless it's on the. Well, we do have a YouTube channel, and I guess that's
People could share us with their
thumbs up.
friends. That is the way to show that you like us. I don't give a shit
Right.
about a thumbs
Thumbs
up
up.
or a like or a retweet or anything.
It's
Just share
engagement.
us with your friends.
Come
Just
on.
tell another nerd about this nerd stuff.
We are the world's #1 electronics podcast.
My parents are in town right now, and my parents are asking how the podcast is going, and they're like,
Oh.
"Oh, well, how many nerds? How many people do you have listening?" And I was like, "Oh, we've got a couple thousand nerds or a couple of thousand listeners." And my mom goes, "Oh, that many nerds?" And I was like, "Mom,
A couple of
you did not just
thousand,
say that."
We're at least 5 digits.
I know, but it was more about the nerd thing.
Okay,
So
right.
yeah.
Yep.
My mom just said, "Oh, that's a lot of nerds,"
Yeah, right. So you're saying your parents care more about what you do than your own wife?
No, she was also very interested in the number of
right,
nerds.
okay.
Yeah. She was just not as blunt about it.
All right.
It's a term of endearment in the Gamble household, just so you know.
You're right. Okay. Yep. And Renesas acquired Dialog Semiconductor.
Oh, you're just sneaking in that news at the end? Yeah.
Yeah. Does anyone care?
Yeah.
No one cares.
Dialogue was supposed to be bought by someone else. I forget who.
Oh, really? Okay.
Yeah.
God, I can't remember the last time I used a Dialog Semiconductor part. Jeez.
Yeah, I mean, they're automotive, so
Yeah.
good luck.
Oh, boy. Yep.
Yeah.
Anyway, catch you next time.
See ya.